Interior angles of a polygon, you may be asked about interior angles of a polygon. So it could be that they give you a triangle or a quadrilateral, and we know that that's 180 and 360, but they could give you a 7-sided shape or a 15-sided shape. You need to know what the sum of the interior angles are for those. This little diagram here just explains what we, or how we find, or what we mean by an interior versus exterior. Remember that you have done this before, but remember exterior angles are where if you extended the lines in the same direction, then that would be the exterior angle. What I want to make sure that you're not thinking is if this is interior, oh that's not in, that's not the exterior, okay? Because exterior angles are formed like this. So you pretend like you've extended the line, and so what does that mean is special about interior and exterior angles? They add to 180, they're not equal. So they would always add 180.
You need to record.
I thought I was. Yeah, you are. I think I am.
What? No.
So now we've got a little bit of I think, yeah, I yeah, that was recorded. Based on the number of triangles that each polygon has, your interior can be, your shape can be split up with a number of triangles. You will find that there's a formula to find the sum of the interior angles of any n-sided shape. Does anyone remember what it is? Okay, so whatever number of sides the shape has, you subtract 2 from it, and then you multiply that by 180. The reason being is because each polygon, if you cut it up into triangles, you're always going to have 2 fewer triangles than you did the number of sides. Okay, and that means that that's going to be what we multiply by 180. So that's where it stems from, or you can just remember that rule. Okay, so the sum of the interior sides, so n it says here is the number of sides. Okay. Exterior angles of a polygon are nice and easy. Exterior angles of a polygon always add up to 360. So where does it say that? No, it says the interior and exterior adds to 180. But the sum of the exterior angles of a polygon is always 360 degrees. Okay, so whether it's got 11 sides, 3 sides, 760 sides, the sum of them is always 360. What that means is that there are some questions that ask about interior angles. It's often easier, so it might say, here's a polygon, so I'll draw a new diagram. Page. So here's a thing, they'll say, this angle here is 100, no, let's say, oh my gosh, just pick a number, 83 degrees, okay? What's going on? So they might say that the interior angle is 83 degrees. And it's a regular polygon. How many sides does the shape have? So you might look and go, well, I don't know. The best thing to do is to say, well, if I know that the interior angle is this, I can easily find my exterior angle. What's the problem? Really childish right now. Okay, so they might say it's a regular polygon, the interior angle is this, how many sides does it have? Now, if we knew the sum, then we could divide our sum by this angle and tell us how many sides. But we don't know the sum because it differs for each polygon. But what doesn't differ is the exterior angle. So what you would do is to say, okay, well I know that my exterior angle must be 97. Yes, how do I know that? Yeah. And then you do 360 divided by 97, and that will tell you how many sides the shape has. So you would find the exterior, so you focus on the exterior angle rather than the interior because we know the exterior angle is always at up to 360. So that's a lot easier when it comes to do. Now there is some fancy pants way you can set up the formulae, but it's just so much easier to focus on the exterior angle. So if one of those kinds of questions come up, then that's what you will do. Okay, happy with that? Yes. Oh gosh, this is annoying. So now we're on to circles. What to do? Before we start looking at circle reasons, I just have to make sure that you are confident with your terminology for circles. Not everyone is. I haven't shown the centre of these circles, I do apologise. But what's the radius? From the centre to the outside. If you need to write yourself a description, then please do so. So it's the measure from the centre to the outside edge. Diameter?
All in one extra number.
I need a bit more information.
It's
Through the centre. Okay, the diameter has to go through the centre. What's the connection between radius and diameter? Yeah, so the diameter is 2 lots of the radius.
I know what a chord is.
A chord? What's a chord? Yeah, it's a line that cuts through the circle from one side of the circumference to the other, which means that the diameter is a chord. Yes, do you all see that?
Yeah.
So if the description is from one side of the circumference to another, then it means that diameter is a chord. It's a special chord, it's the longest chord. Okay, so the diameter is the longest chord. Sometimes that is a question. What's the longest chord of a circle? So you would say that was the diameter. Tangent. Do you know what tangent is?
Yes, it goes a line on the outside.
It goes
out. It goes like this. It like rests on the It goes like this. It's like that.
What does it do to the circle edge? It just touches it. So that's not what she was looking at. But that's outside the circle. I remember. Right, okay, now, what? I'm not enjoying this.
Sorry.
Okay, so the tangent is a straight line that just touches the circle edge. Okay, so it's a straight line that just touches the circle edge. Circumference I've done for you, in pretty blue. It's the distance around the outside, so it's a special word for the perimeter. How do we find the circumference of a circle? 2 pi r or pi d. Okay, you don't get given those anymore, so you do need to know that. Okay? So you will also need to know the area of the circle. But I will give you sneaky hints as to how to use another formula on the sheet to help.
I know what a formula is.
So an arc, what's an arc?
I don't know.
It's a tiny bit of the circumference. So any amount of the circumference. Okay, so an arc is a piece of the circumference. And sometimes they will refer to minor and major arcs. Hopefully you appreciate a minor arc would be a small one, and a major arc would be a big thing. So what we see here, it's like any kind of angle though. If you just did that, you've actually got this angle and this angle. So here, when you've got an arc, you've got this baby bit and you've got this massive bit. So just if they've got the word minor and major, just know that they're referring to the smaller or larger piece. Sector and segment is something that people often get mixed up. Sector.
Is it everything but a part?
No.
Is it like just a random?
No.
Is it like a piece of pie?
It is a piece of pie. Yes. Okay, so a sector is a slice of pie, piece of pie. So it's from the centre, it's got 2 radii and an arc. So it's the area formed from 2 radii and an arc. 2 radii. Just there. A segment
That's just like a line.
is formed by a chord and an arc. Okay, so a segment is a chord and an arc. I actually think this does look like a piece of orange segment. May help, remember? Yes.
Wait, is radii 2 eyes?
No. Huh?
Radii 8.
Yeah, 2 eyes. Right, another useful thing to remember is that if you've drawn 2 of these, that means that you have actually formed an isosceles triangle because these 2 legs have to be the same, so they both come from the center. Therefore, this would be an isosceles triangle, which means that these 2 bad boys are equal to each other. Okay? So when you're doing what we're going to do next, so when we're looking at circle theorems, you are always looking out for certain features that they've shown you to help determine which angle reason we're looking at. Okay? Here we go. These are, again, more reasons, like the ones I was talking about, straight lines, that you just essentially have to learn. Now, what I've got for you, and I'll give it to you today, is a double-sided sheet with all of the angle reasons on. So it's one sheet of summary of everything. However you learn them, it's up to you. But if you like a good flashcard, that's something you can put on a flashcard and just learn it. But I will give you the picture of all of them. So angle in a semicircle. It means that if we have a semicircle, the angle that is at the circumference will always be 90 degrees. So if I have drawn 2 lines like this would be 90 degrees. If I had drawn it here, I know that this would be 90 degrees. So if you've got an angle at the circumference that stems from the diameter, then that's going to be 90 degrees. Okay? Chords of a circle. This is less commonly talked about. Okay, but if you draw a chord, so here's my chord AB, then the line from the perpendicular line from the center would bisect that chord. So this measurement here would be equal to this measurement here. Okay, so if that's a right angle, then those 2 distances are equal. Oh, sorry, if I'm 100% honest, I've never even seen that used in an angle reason question, but it was in the textbook, so I'll just read it. This is a very common one, angle at the center. Have you done any of these before?
No.
99? Some of them? No.
I don't think we went into this one stuff about the rules. We were just friends were making notes and then.
Okay. So, if you have a circle, if the center is shown, it's generally shown with the letter O, just as a pointer. So we normally see in these diagrams, if it's got an O marked, it means it's the center. I really mean it enough, please. That you can sit back there if you keep drawing. So, from these 2 lines here, A and B, sorry, these 2 points A and B, if you're able to draw 2 lines to the center, and from those same 2 points, 2 lines to the outside edge, it means that this angle at the center is twice the angle that is at the outside edge. Now, they don't always look like this. Sometimes they look quite obscure, and I've got some diagrams of ones down at the bottom to show you how different some of them look. So just remember, from any 2 points on the circumference, if you are able to draw lines to the center and then to the outside edge, then this one at the center is twice the one at the outside edge. Okay. Now, when I'm talking about this, notice they both hang down in the same direction. So this hangs down, this hangs down. Again, I'll talk more in a minute about some of the directions. Angles subtended, fancy pants word, and by the same arc, so, or form. So if I've got, again, this point A and B, if I can draw 2 lines to the outside edge, And if I can draw anywhere else to the outside edge, it means that these two angles are equal. It would also mean that these two bad boys are equal as well. Often I refer to that one as bow tie. Sometimes talk about this being arrowhead. Not always.
And then the
Arrowhead.
The vertically opposite ones are equal as well.
And then yes, because these are straight lines, we know they have to be equal.
Can you explain what you mean?
Can you say the last name again?
Explain why.
I don't know why. It's just geometrically that's the case.
Can you explain the last one again?
This thing.
From
If from any 2 points on the circumference, you can draw to the outside edge, to anywhere else on the outside edge, those two angles will be equal to each other. Okay? Now, these ones here. This doesn't look like that arrowhead thing, does it? But it is still angles at the center. So you need to look out for, if they've marked the center, it means it's probably going to help you somehow. And it's probably going to be angles at the center rule. So this one here is going to be twice this one outside here. Because they both stem from these 2 points. We've drawn it to the center and to the outside edge. Okay? So while some people look at this and go, oh, look at the bow tie. No, because this one doesn't go out to the circumference. This one just goes to the center. This one here, often a question will label this angle here and ask you about this one. And people think, oh look, it's angles at the center because this one goes to the center, this one goes to the outside edge. But this is what I was saying about the hanging the same way. But if you're asked about this angle here, you need to first of all know this angle here because they're both hanging the same way. Do you understand what I mean by hanging the same way? It's really not mathematical terminology. I think it hopefully makes sense. This one goes through the center. Oops. But still, that goes to this from here, goes to the center, goes to the outside edge. So this one is twice this one. As it says here, the angle of the semicircle is a special case of the angle at the center because we're starting at these 2 points here. We're going to the outside edge, and then and literally we're going to the center. So that's why this one's 90, this one's 180. Tangents. Tangents. If a tangent meets the radius, and it's only if it meets the radius. Okay, so if there's some other random line, it's not going to be this case. But if it comes from the center, then this angle here and obviously this angle here would be 90 degrees. So if a tangent meets a radius at 90 degrees. And for all of these questions, or all of these angle reasons, the name of it is on the left-hand side. So that's the bit that you would write if it says give reason. Yes? So giving the reason, that's this here. You would just have to say radius meets tangent. Done. Finished. You don't have to say at 90 degrees. And tangents from an external point. So if I've got this outside point here, and I were to draw a tangent, or two tangents, sorry, then it means that where it touches the circle edge, in both cases, those lengths would be equal to each other. So in other words, you could again form yourself an isosceles triangle there. Okay, so in those cases, from any external point, your tangent where it meets the circle edge, or tangents where they meet the circle edge, those lengths will be equal. If a circle can be drawn through 4 points, we call the shape, inside a cyclic quadrilateral. Okay, so it would be a cyclic quadrilateral. New rules about cyclic quadrilaterals is the opposite angles in a cyclic quadrilateral would add to 180. So if you've got a four-sided shape, or if you can form a four-sided shape or see a four-sided shape, then the opposite angles would add to 180. Exterior angle of a cyclic quadrilateral, and it's a little bit similar to the exterior angle of a triangle, although this exterior angle here would be equal to this interior one opposite it.
Do we have to know how to work these out? Or just recognize them?
You need to recognize, you may have to give a reason, so that's what you need to kind of match this column here with this column here.
Okay, so nothing like that's
Basically, you're just going to get loads of pictures of circles and asked to calculate angles. So you need to recognize all these reasons. Some will be easy, some will be harder. Two more. Alternate segment theorem. And I really don't know why, but I think this looks like a windsurfer. So here's his, oh shush now. Here's his board, and there's his sail. I don't know why. Person's not there. I've just erased all my markings. So this angle here is equal to this one, and this angle here is equal to this one. Okay, so the opposite angles are equal to each other. Now notice this doesn't go all the way through, it just goes up to the sail. And this one's the opposite bit. Okay, so that, and note this doesn't have to go through the centre. Okay, so that's your alternate segment theorem. Chord bisector, again this one not so much used, so let's put a bracket around this bad boy. But if you bisect any chord, it's going to go through, or especially if you've got two chords, it will go through the centre. So if you're asked to find the centre of a circle, you could draw any chord, bisect them, perpendicular bisect them, and you will be able to find the centre of a circle.
Isn't that just the chords of the circle rule?
Well, that goes the other way around. So that says that if you've got the radius, if you've got the, here, then that's going to be bisecting this. So it's like if you bisect that, you will find the centre. It will go through the centre.
But it's
Yes, same for intersecting chords. I always forget these ones. I always forget which way around they go. Okay, so we've got two chords here. So AP, this baby length here, multiplied by its partner, so the other side of its chord, is equal to this length multiplied by this length. Okay, the kind of situation would be is they might have said find x if this is 7, this is 11, and this is 2. Random numbers. Okay, so you would know that 2 multiplied by 11 would equal 7 multiplied by x, and you'd be able to find x. That's the kind of question that could come up. Intersecting chords outside of a circle. Again. So AP, long, versus outside short is equal to long versus outside short. Multiple outside short versus. So they're just rules that you need to, again, you just need to learn, unfortunately, in order to calculate some stuff. That's helpful, is it? Don't you feel really good about themselves? Yeah. Awesome. Great. Great teaching stuff. But I did